Okay, we've been given a question where it's been asked us to differentiate y equals 1 on x using the limiting chord method. Now, just as a refresher, the limiting chord method is if we have a function y is equal to f of x, the derivative y prime will equal the limit as h approaches 0 of f of x plus h minus f of x all divided by h. Great. So basically what we have to do is we just have to enter in y equals 1 over x into this algorithm and then do a little bit of algebra to simplify it down. So we'll enter in y equals 1 on x. So the limit as h approaches 0 of f of x plus h, if we enter this in, we're going to get 1 divided by x plus h, subtract 1 over x, all divided by h. Now this is equal to limit as h approaches 0. Now what we're going to do here is to even start to compute the numerator of this expression, we're going to have to get these on the same base. Now the easiest way to do that is we're going to multiply the bases together and then we'll be able to find the relevant numerators as well. So we'll do that over here. We have 1 over x plus h minus 1 over x. If we multiply the denominators together, we're going to get x squared plus xh. Now, the x plus h is being multiplied by x, so 1 has to be multiplied by x, so we're going to get x minus. The x is being multiplied by x plus h, so the 1 has to be multiplied by x plus h. So we have x plus h. And this will simplify down to negative h divided by x squared plus xh. Okay. So we'll put that into our function. We have negative h divided by x squared plus xh. Now, all of this is divided by h as well. Cool. So we know that division is just multiplication by the reciprocal, i.e. like a divided by b is the same as saying a times 1 over b. So what we can do here is we can write this is going to be the limit as h approaches 0 of negative h divided by x squared, worst x squared ever, x squared plus xh. And this is going to be multiplied by 1 over h. Cool. So, what we're then going to do is we're going to multiply the h by the x squared plus xh denominator. And what that will do is we'll be able to cancel out this h with this h at the top. So this and that will cancel, making 1s. And we're just going to get negative 1 over x squared plus xh. So this is going to be the limit as h approaches 0 of negative 1 divided by x squared plus xh. Now, once we get to this point where we think we can't really simplify it any further, we then do what's called like a limiting statement. So we actually take the limit as h approaches 0. So the way I do this is I write as h approaches 0, comma, x squared plus xh will approach x squared, because this function here, as h approaches 0, will approach 0. So what happens here is as h squared approaches 0, x squared plus xh approaches x squared, and we can write, therefore, the derivative is equal to 1 over x squared. I hope that helped, and if you need any other videos, just either send me an email, which I'll put in the description below, or just ask in the comments.